Today's webinar is about serverless CRUD application with AWS infrastructure. And for the folks who don't know, CRUD stands for create, read, update, and delete from a database perspective. So essentially, we are talking about an application that you can use that has a front end and it is connected to a database on the back end, and it allows you to create, read, update, and delete. And it is going to be a serverless application. Serverless application on AWS is very important because you do not have the overhead associated with instance and uh, server overheads like CPU, memory, and RAM, and it allocates resources on the fly, and it is more economical. So today's talk, we are going to start with an introduction of what is the project all about, VCs, what are VPCs and subnets, introduction to security groups, what is a NAT gateway, what is the AWS native database for serverless operations, and how to implement it on a serverless side. Okay, so from a serverless CRUD operations and from a serverless CRUD perspective, we will discuss the Lambda functions available, that is the CRUD, then connecting the Lambda functions to an Aurora serverless database, benefits of a serverless architecture, securing data in a serverless environment within AWS, uh, backup and recovery, and conclusion. So we have limited time. I will go on a little speed. So this is a typical AWS architecture, and uh, what within an architecture is a virtual private cloud, the VPC, which allows customers to map their private network over to AWS in a pseudo dedicated environment. That means that users have their own private cloud, and they can allow public or private access if they like. Otherwise, it is exclusively for client and its users usage. So this is a public subnet that allows external communication, and all the networks within the AWS, these are called the subnets, utilize a NAT gateway, which is a network address translation gateway to connect with external world. The function of a NAT gateway is that uh, every traffic has to pass through it to an external user that is outside AWS or within other VPC accessing via subnet. Um, it it is not able to see the IP address of the private subnet. So any computer which is over here or any resource, uh, it translates the IP address to a public IP address and keeps the mapping within itself so that the no one can discover any resources on its own. So we will explore how to create a serverless CRUD application using AWS services. Um, as I mentioned, we will leverage AWS components such as subnets, security groups, VPCs, NAT gateway, and Lambda functions. And even within the component itself, the internal communication goes through a security group. So only the allowed component are allowed to access the database resources, and they have to have an authentication, um, which is implemented by this security group. Lambda is the serverless function. Let's move on to the next slide. So just a quick rundown of VPCs and subnets. I just provide a high-level overview. VPC is to use to isolate resources, public and private subnets for enhanced security, We can assign IP address range to each subnet. VPC is logically isolated virtual network that enables you to have complete control over the network settings, such as IP addresses, subnets, routes, tables, and network gateways. Subnet is a range of IP addresses in VPC, and subnets are created to partition a VPC's IP address space into smaller, more manageable segments. What is a security group? And each subnet is associated with the specific availability zone in a given region. Security group implement security. So what are the security groups? We implement security groups for Lambda functions and RDS Aurora. It acts as a stateful firewall, controlling inbound and outbound traffic at the instance level and secure communication. What is NAT gateway? I just explained the NAT gateway in the previous slide, so I'll move on. What is a RDS Aurora serverless within AWS? In our case, we are going to create RDS Aurora serverless database in the private subnet to store data. This database is designed to automatically adjust the capacity based on the actual needs of the applications. It eliminates the need for manual intervention in scaling the database, making it cost-effective and efficient. In general, Aurora is a serverless RDS, serverless database and RDS umbrella. What are the CRUD operation? As I mentioned, it's create, read, update, and delete application on AWS involving various AWS services to build a scalable, cost-effective, and maintainable system. Lambda function, what is the Lambda function? Lambda function uses Python for each CRUD operation. Lambda is serverless computing service provided by AWS. It allows you to run code without provisioning or managing servers, which means you can focus on writing your application while Lambda takes care of the infrastructure. That means that you can invoke Lambda function. AWS takes care of an invocation, resources needed, and scalability. Every Lambda function has a time bar. It cannot run forever. There is certain times under which it has to expire. Although you can change the time, but that's on a special need basis or not often. It operates on an event-driven model where the code, which is the Lambda function, is executed in response to events or triggers. So what are the CRUD operation? Quickly, in the create operation implements a Lambda function to handle the creation of records in the RDS. This function validates input, insert data into the database, and returns a success message. What is read operation? It retrieves record from the database based on a specific criteria. The criteria can be any index field, any field that is indexed, name, address, social security, or what have you, and implement necessary error handling and response formatting. And what is an update? Basically, an update is what it sounds like. It updates a record in the database. It ensures that function validates input, performs the update, and returns an appropriate response, which can be success, failure, overwritten, etc. What is a delete operation? Delete is implementing a Lambda function to delete records from the database, including input validation and error handling to ensure data integrity. So how do we connect Lambda function to RDS? So the steps are as follows. Step up IAM roles for Lambda functions with necessary permissions to interact with RDS serverless, and use environment variables in Lambda function to store database connection details securely. So none of the IAM roles, none of these is hard-coded. These are done well in advance. When we are defining Lambda function, the IAM roles are advanced, uh, are uh, are set up in advance so that uh, uh, every every access of Lambda function is predefined and it does not do anything else. And it uses environment variables, and we will something that we can discuss a little later. So before we go into the details, what are the benefits of serverless architecture? Serverless computing allows you to pay only for resources you consume during the execution of your code, something we just discussed to start with, rather than pre-allocating and paying for fixed server capacities. No need to manage and maintain servers, reducing operational cost, scales based on demand. So if there's a more demand by the executed code for more resources, these can be scaled to a certain level that is defined um, prior to provisioning the code. Automatically scales based on demand. Um, Serverless platforms can handle a varying number of concurrent executions, ensuring optimal performance regardless of the workload. Developers can focus on writing code without worrying about server provisioning, scaling, or maintenance. Rapid deployment and continuous integration are simplified, leading to faster development cycles. Serverless architectures provide built-in redundancy and fault tolerance, ensuring high availability without the need for manual intervention. It's important to note that Lambda functions themselves don't directly provide high availability. Rather, they can be part of an overall architecture defined for high availability. AWS resources and paradigms related to high availability, meaning multiple availability zones, disaster recovery, point-in-time recovery, etc., have to be configured as usual. RDS serverless RDS scales automatically to accommodate changes in workload, ensuring efficient resource utilization and improved performance. Um, no server management tasks such as patching, hardware maintenance, or capacity planning, leading to a reduced administrative overhead. So, how can we secure data in a serverless environment? Enable encryption at rest to protect data on the disk. Amazon Amazon Aurora supports both server-side encryption and customer managed key service KMS. So it leverages secure services that are natively provided by AWS. So just imagine it is running on a server on an instance-based model. The paradigm of security encryption will be the same for the data at security and data and transmission as well as data at rest. We need to configure security groups and network ACLs to control inbound and outbound traffic, to inform the Aurora RDS instances. And by the way, I will have some time later on for some question and answer. So please hold on to your questions. It uses VPC for additional network isolation, implement so a secure data will, of course, leverage VPC, subnets, security groups, and a NAT gateway for network isolation. Implement strong authentication mechanisms by using identity and access management roles. We need to enable CloudWatch logs for Aurora to keep database logs, to capture our database logs, including query logs. We need to, operationally, we need to review and analyze logs for any suspicious activities like failed attempts to log, failed authentication attempts, and so on. And use parameter groups to manage database configuration settings securely. Again, database is also serverless. It needs to be configured in the most efficient way. We need to regularly review and update parameter groups to align with security best practices. And the Aurora database engine and software uh, is updated already to benefit from the latest security patches and improvement. This is transparent to the operationally. It is done by the Amazon Web Services. So we need to monitor and alerting using Amazon CloudWatch to receive notifications about security events or anomalies in the database performance. If there's any gateway error or timeout errors or any execution errors that the serverless database is generating, these are logged in the CloudWatch. So it is essential that we keep monitoring the CloudWatch logs. And we need to regularly back up the database and test the restoration process to ensure data recoverability in case of security, data instance, or data loss. So how do we back up and recover database? I will quickly go through it. By default, Aurora creates automatic data backups known as snapshots of your database volumes and the cluster. These snapshots are taken regularly based on the retention period you specify, which can be between 1 and 35 days. In addition to automated snapshots, you can create manual snapshots at any time. These manual snapshots can be retained for as long as needed and are not subject to automated retention policy. The retention period for automated snapshot is set when you create or modify an DB cluster. This period determines how long RDS keeps automated backup before deleting them. Retention period is 7 days, but can be adjusted. You can also backup data in S3, which is native storage provided by AWS. Amazon Aurora uses a distribute and fault tolerant storage system, and snapshots are stored across multiple availability zones. Aurora supports point-in-time recovery, allows you to restore your database to any specific second during the retention period. So PITR is super important. If you can configure it for the serverless database, Aurora, it will allow you to restore your database to any specific second level granularity, which is super important and useful. This feature is useful for recovering data to a specific point before accidental data changes or deletion. Since the database is serverless, it is not being, so it is important that you have point-in-time recovery, especially for mission-critical databases. Aurora automatically encrypts backups at rest using KMS. This provides an additional layer of security. Automated snapshots are managed by RDS and are taken periodically based on the specific retention period. Older snapshots are deleted automatically to comply with the retention policy. This is done as part of the designing process. You can also copy snapshots to other AWS regions or share them with other AWS accounts. This can be useful for disaster recovery or creating replicas in different regions. RDS provide CloudWatch metrics and CloudTrail logs that allows you to monitor and track backup related events. You can set up CloudWatch alarms to receive notification based on specific criteria such as backup failure or low storage space. Okay, so what is the conclusion? Essentially, by combining AWS infrastructure services and serverless function, we can create a scalable and resilient architecture for a CRUD application. This approach allows you to focus on application logic without managing the underlying infrastructure. As your application grows, The serverless architecture ensures automatic scaling and cost efficiency. This example serves as a foundation for building more complex serverless applications on the AWS cloud platform. So we have a complete set of the creation of a CRUD database and Lambda code. So uh, uh, you can go to the AWS infrastructure blog, it's https://museworks.com, uh, and follow this path, CRUD application with AWS infrastructure. And it includes codes, screen, video clips of the working code, and all the features are demonstrated in this block. So you can visit it on the Museworks website, and if there are any questions, feel free to uh, let us know. A few questions have come, so I will quickly go through them. We have limited time. One is that um, how does point-in-time recovery enhances data recoverability, and in which scenario it's useful? I think I've already explained that when you need to have a granular recovery, you have a mission-critical application, you can have a second-level data restore to maintain consistency and reliability. Question number two, how does the combination of AWS infrastructure services and serverless functions create scalable and resilient architecture? A lot of details can be provided as an answer. I'll just quickly provide the salient features that serverless functions enable you to execute code in a serverless manner, automatically scaling based on number of incoming requests. So as the workload varies, the capability is managed by the serverless infrastructure. The Lambda function scales the execution environment in response to the number of incoming events, ensuring that you don't have to worry about provisioning or managing server. Serverless function also inherent benefits from built-in redundancy and fault tolerance. um, Lambda function replicates function across multiple availability zones. Okay, this is a few of the benefits. Um, there's another question, in what way does a serverless approach allows developers to focus more on application logic and less on infrastructure management? So that we have already discussed that most of these serverless function you don't have to worry about provisioning servers, configuring or managing or patching them, and so on. The serverless infrastructure does that for you, and it typically operates on a pay-as-you-go pricing model where developers are charged based on the actual usage of resource. This element eliminates the need for capacity planning and allow developers to focus on writing codes and not worry about over provisioning and paying extra for the over provisioned resource that are not needed. Um, Another question, how does serverless computing contributes to cost efficiency in comparison to traditional server-based model? Again, as we addressed in the previous question, you don't pay for ideal server capacity. Traditional servers, less server-based models are a fixed cost, whether you are using them or not. Serverless uh, is pay-as-you-go model that scales on peak and scales down on when the requirement goes down. It provides fine-grained billing, charging for exact resources consumed by each function or event, which makes it very cost-effective. Let me see if there's any other questions. Um, what measures can be taken to implement strong authentication and authorization mechanism using IAM roles? IAM roles provide a secure way to grant permissions to entities such as users, applications, or services, enable IAM database authentication for your RDS instance. It will allow you to authenticate your database using credentials instead of traditional username and password that can be hard coded and copied. So it uses an IAM model, which is a more secure as centralized AWS native way. Okay, I do not have any other questions. So that brings us to the end of time for a quick 30-minute webinar. Please refer to the blogs on the Musebook site. There are also other useful blogs, white papers, and case studies with implementation specimens, codes, etc. Feel free to visit Musebook's website. And if there is any more questions, please feel free to write them at info@musebook.com. Thank you. I'll stop recording.